Below the Cambridge Zoology Museum lie rows and rows of glass jars. The Sanger Institute brought these samples to Cambridge in order to create a comprehensive genomic resource of Lake Malawi cichlids. With Malawi, Mozambique and Tanzania forming its basin, Lake Malawi is the 9th largest lake in the world. The lake was said to be home to 15% of the world's freshwater fish species. The family Cichlidae dominates the lake's fauna, both in richness and diversity. In total, the lake is home to around 750 species of Cichlidae, 99.5% of which are endemic. These corridors of glass therefore represent an invaluable resource for the study of a unique adaptive radiation that has produced hundreds of young, ecologically diverse species. They also carry with them the important stories of the threats to these cichlids' home. The lake is not only significant as a home to unique fish species, man has been reliant on the lake for thousands of years, and the lake continues to support the rapidly growing population of Malawi. In the 1990s, 70% of Malawi's animal protein came from fish. Now, over 70% of Malawians still rely on the lake and its catchment for livelihoods and survival needs. But the fish populations are dwindling due to a gang of threats. While the catch in the Malawi section of the lake has been stable at around 30,000 tonnes per year, the effort per unit catch is increasing. This decline is not a typical tale of large-scale commercial trawling devastating stocks, but rather a steady erosion as small catches by many individuals accumulate. Artisanal or small-scale fishing predominates, forming 90% of the total annual landings, so commercial trawling has a relatively minor impact on the resource, although not an insignificant one, as when stern trawling was introduced in 1972, there appeared to be a noticeable depletion of larger, slower-growing, late-maturing species. Anyone can fish in artisanal fisheries, each fisherman acting according to their own self-interest, contrary to the common good of the lake. This curse of the common resource is only amplified at an international level, as not only are there huge numbers of stakeholders in Malawi, but fishermen from Mozambique and Tanzania also draw from the lake. Thus, this is a trans-border problem of great complexity. The problems facing the ecosystem are not limited to overfishing. Soil erosion is a major problem in all catchments that drain into the lake. This is linked in part to smoking stations, commercial tobacco growing in Tanzania, and subsistence farming on steep slopes. Such practices degrade the surrounding catchment and create hypertrophic conditions in the lake margin, establishing alternate equilibria. Over time, this encourages the invasion by hyacinths and drives the loss of native fauna and flora. All of these additional problems share a similar theme to overfishing. They result from the massive strain placed on the ecosystem's provisioning services, and they cause lasting damage to ecosystem function. Poor management of fish stocks does not only threaten Malawi's food supply. The decline of species such as Tromatocranus placodon also causes a rise in disease incidence. Schistosomiasis is a parasitic disease. Its larvae penetrate the skin during contact with infested water, and worms mature within the blood, where they release eggs, causing growth stunting, anemia, and learning difficulties. Over 66.5 million people globally were treated in 2015. 200,000 people die every year, making it the second most devastating parasitic disease after malaria. However, prior to 1985, Lake Malawi was free from the disease. The dramatic rise in incidence is due to the decline of the predators of snails that host the parasite's larval stage, so the overfishing of molluscivores such as Tromatocranus placodon is linked to a rise in disease. An outbreak also occurred in the Senegal River Basin after the construction of Diama Dam. The dam blocked the annual migration of the African river prawn, which is the natural predator of the snail hosts. Reintroduction experiments were highly effective in reducing numbers of infected snails. Yet Lake Malawi offers a more complex problem for conservationists. While ultimately the solution could be simple, reduce catch sizes, this ignores the more insidious driving forces behind the lake's decline. The lake and its catchment are at the mercy of a growing, poor population, with little alternative to damaging farming or fishing. Malawi also suffers the immense burden of some of the highest rates of HIV and AIDS in the world. So conservation of the lake is a long-term challenge, eclipsed by the short-term needs of its people. To save this home to so many remarkable species, any sustainable conservation strategy will have to work with both nature and man in mind.